Okay, I'm going to break you off into groups today. This is the groups you're going to stay in the whole time here. Can we just have these three front groups? You guys are going to be group one. Okay, group one. You guys right here, group two. And then you guys right here are going to be group three for me. All right, group three. Before we start on the task you got to do in your group, have we heard this word somewhere before? And we have, but anybody remember what figure we heard it in before? Mid-segment. It was last unit when we did quadrilaterals. In a trapezoid, yes. Let me just refresh everyone's memory. You don't need to copy it down, but just let me refresh your memory here. A mid-segment. Anybody remember how a mid-segment was formed in a trapezoid? When I connected the what? Anybody remember? When I connected the... Anybody now? When I connected the midpoints of the non-parallel sides, yes. And here we go. I'm going to keep going. Do you guys remember the 2 facts about a mid-segment of a trapezoid? What did I know about EF? Anybody remember the 2 facts we came up with? Thomas, do you remember one of them? Yep, so it's parallel to the 2 bases, AB and DC. And did anybody remember how we found its length? Anybody remember? Miko, what do you got? We took half of the 2 bases added together. All right, that's in a trapezoid. Today, I'm going to show you that same mid-segment, but now in a triangle. And you're going to see how close the 2 facts for the trapezoid come to the 2 facts in a triangle. All right, so here's how we're going to get to the 2 facts. You and your group right now, figure out what group you're in, I assigned you to, and find the midpoints that you're asked. Do not do any other group's work. Find your midpoints. Talk with each other, actually. Yes, make sure everyone in your group has the same midpoints. Heck, make sure you know the darn formula 20 weeks already into the season here. Find the midpoint of your respected line segments, please. Make sure your points are actually on your lines. I'm going to go backwards here. Group 3. What did you find for point E? Group 3. Anybody from group 3? What did you find for point E? You're pretty confident? 5, 7. Make sure if you weren't assigned to these, make sure you copy them down now. And what about point G there, group 3? 3, 2. So everyone take a second right now, jot down point E and G, and please plot them and draw in segment EG. All right, 5, 7. And 3, 2. Draw it in. Group 2. I don't have to ask you point G. We know that already. So what'd you get for point F? 8-1. Make sure everyone take a minute right now, jot it down and graph it and draw it. And group 1, just make sure you guys matched up. Hopefully, I don't need to ask you. We've already found them. And everybody else, if you didn't have those, make sure you graph in EF while you're there, please. Okay. Look what we've created. 3 mid-segments. How do I know they're mid-segments? What did you guys just connect on each side? The midpoint. So these are mid-segments. We'll write it down in a second. All right, let's find some facts about these mid-segments. So now, go down to question 1. Each group right now will find the distance of 2 sides. A side of the original triangle and a mid-segment length. Okay, so now take each side length you're responsible for, find the distance, and because we are in an above average level class, those distances, please, simplest radical form. Okay? Every group should be able to break down at least one, if not both of your radicals. Okay, so go ahead, distance formula, talk it over with your group, Pythag if you want, whatever floats your boat here. And you should notice a little relationship between the two if you've done it correctly. Discuss with your group when you're done. Discuss with your group. You should at least break down one of the radicals. One group should be breaking down both. Check with your group. Check with your group. Guys ready here? I'll start with group 1 this time. Group 1. Anybody got the distance of AC in simplest radical form? Group 1. Everyone else, make sure we jot it down. Group 1. 6 radical 5. Good. You should have broke down the square root of 180. And how about EF? Oh, 3 radical 5. Look at that, huh? I believe they have some relationship. Group 2. You got AB for me. Anybody in group 2? AB? 2 radical 26. Nice job. You broke down the square root of 104. And how about FG? Radical 26, yep. Two sides that had the same relationship. And group 3, what do you got for me? BC. 2 radical 29, breaking down 116. Nice job. And how about EG? Square root of 29. Nice job. So hopefully we're starting to see a relationship between the mid segments and the sides. Maybe. We'll talk in a second. Last thing I need you to do as a group. Now do the slopes. Rise over run. Here we go. Do the slopes for me. And hopefully you guys find a pattern with the slopes. So same mid-segment, same side of the triangle, of the original triangle, finding the slopes. Make sure we all match up. Okay. Okay. All right, let's start with group 2 this time. Group 2, what did you find the slope of AB to be? Negative 1/5. And what about the slope of FG? Yep. Group 3, slope of BC? 5/2. And what about the slope of EG? And that's going to get my OCD kicked in. Let's try that again. And group 1, slope of AC? -2, slope of EF. In geometry, when the slopes are equal, what do you usually know about those lines? They are parallel. Okay, so do we figure out the 2 facts now? Because a couple people are going to tell me in their own words. What do I know about a mid-segment? Okay, here were the distances, and here were the slopes. All right, so let's go and figure out the 2 things we know. What are we calling all those segments again that we joined by the midpoints? Okay, it's called the mid-segment. No big deal. All right, there's the mid-segment. All right, based on all that work we just did, here you go. A mid-segment is two things we just learned about it. Okay, 2 things we just learned by doing distance and slope. So what a mid-segment is, describe it for me. Let's start with 18. 18. Okay, let's start with the distance formulas that we did. All these mid-segments are what of the sides we picked? Half. Okay, but now how do we describe, it's half of what? How do you describe what it's half of? All right, so let's do that first. So a mid-segment is half the length of the, ready? I'm going to start calling that side the third side. All right, half the length of the third side. What do I mean by the third side? Everyone go back to the graph. The third side is the one that doesn't connect the midsegment. So everyone ready? Midsegment EF, what's its third side going to be? AC. GF, what's its third side going to be? AB. And what's midsegment GE's third side? BC. So when I say third side, when you tell me third side, we all know what we're talking about. Okay, it's the side that doesn't connect the midsegment. So it's half the length of the third side, and what did we just find out by doing the slopes? It is what also to the third side? 1, Maddie, parallel to the third side. Nice job. All right, so midsegment, half the third side in length, and also parallel to the third side, and I forgot an L. All right, got those. Yes, Caleb, hi. I'm doing good too. Say that again. Similar triangle, what do you mean, all 4? So you mean the triangle that's formed by the midsegments is similar to? They would be, yes. And depending on the side lengths, they may be congruent. No. All right, got your calcs ready? Here we go. RT, well, first, let's go to the directions. What are A, R, and T in the diagram? Midpoints. So can somebody please give me a good vocabulary term for segment RT, RA, and AT? What are all those up there? 15, what are all those segments called? Mid-segments. RT, mid-segment RT. Somebody tell me what its third side is in the original triangle. Here we go, 23. RT belongs to what third side? LB. So the theorem says you take half of LB. So half of 19. Everyone, why I'm picking 19? RT, the third side for that is LB. Half of 19, 8.5. 9.5. How about that instead? Let's try that again. Nobody was going to speak up on that one, huh? I could have wrote chair and went on to the next problem, and everyone would have been fine. Here you go. 23 again. AT. What's the third side for AT? LO. So now I'm going to take half of 35. Let's see how the math is on this one. 17.5. And finally, AR. What's the third side for AR? 18. What's the third side for AR? BO. And that's half of 29. So that'll be, what do we got there? 14.5. Questions there? All right, next one. Before I even begin, how do I know these are mid-segments? You got to take me through your thought process right now. How do I know just by looking, because it says nothing about midpoints. I don't see a word up there that said these are midpoints. How do I know those are all mid-segments? Explain your thought process to me. 12? Where's bisect? What do you mean here? Yep. Because they're both 4, making G a what? That's a midpoint. Everyone see that? 6 and 6. What is that, an I or a J? I is a midpoint. 7 and 7. H is a midpoint. They're all mid-segments. So name me 3 sets of parallel lines. A mid-segment and its third side. A mid-segment and its third side will be parallel. Name the first pair that you have. 12 again. Name a pair of parallel lines up here. HI, mid-segment, is parallel to its third side, BA. Nice. Second pair of parallel sides up here. Here you go, 10, second pair. AC, third side parallel to its mid-segment GH, and I won't ask anybody for a third pair. It's just process. Speaking too loud again. Process. Thanks. I'll be right there. Okay. I'm missing? BC parallel to GI. Okay. Now that you know they're parallel, let's use it to find some angles. 42, BGH. Everyone identify angle BGH for me. BGH. Everyone see that angle? It's 42 degrees. There it is, BGH, 42. I'm asking for BAC. What is BAC? And remember, you just prove lines parallel. You just prove and be able to back yourself up. Because I know most of you know either it's congruent or supplementary. You got a 50-50 shot. All right, congruent or supplementary, those two angles. And you got to tell me what type they are. They got to be special types of angles because they are formed by parallel lines. .22, what type of angles are those? Congruent, and because they are corresponding, good. So that must mean BAC is 42 degrees because they are corresponding. Everyone see they're corresponding. Match right on top of each other. Okay, I'll give you about a minute, no more. Try out number 3 right now on your own or in your group. Try out number 3. Came right out and told you it was a mid-segment on that one. I got a 25 here. What was NM? Double it, yep. And then I'm going to look for the perimeter of the entire triangle now. 28, I got a 28. Or had a 28, nope. 15, 61 units. Got it. Nice job. And the final one, yes, you're going to try this one out on your own now. Does everyone see why P, Q, and R in this diagram? Look at the diagram, why P, Q, and R are midpoints. You got the hash marks, so those are mid-segments. XZ, 6x minus 4. And PQ, 4x minus 5. They are not equal to each other. We've clearly demonstrated that today. They are not equal to each other, so you have to adjust this somehow. All right, I'll walk around, see what you're doing here. Be disciplined. Be disciplined. I'm asking for more than X. Be disciplined. Start getting in this habit. Great, you found X. Reread the problem. Look at your two final segment lengths. Is one double the other? Six x minus 4. Yes, you can, but use 4. You use 2. That's 6x minus 4. Okay, nice job. Remember, tonight you should get a perfect square underneath the radicals for your assignment sheet review.